Welcome to the next course in database engineering. The focus of this course is on database clients. Let's take a few moments to review some of the new skills that you'll develop in these modules. You'll begin the module by learning about the MySQL Python connection, and you'll learn about using pip to install packages or software. You'll then learn how to install a front-end Python client and connect it to a back-end MySQL database. You'll then explore how to establish communication between Python and MySQL to perform CRUD operations. Once you've established a connection, you'll then access a cursor object. Once you access the cursor object, you'll create a MySQL database and table using Python. You'll then learn how to commit changes in a MySQL database using Python. In the third and final lesson of Module 1, you'll explore the concept of a cursor in a MySQL database. You'll learn how a cursor works in Python and MySQL. You'll also review the key characteristics of cursors and discover that they're read-only, non-scrollable, and asensitive. You'll then learn that the cursor class is used to translate communication between Python and a MySQL database. And you also learn how to identify different cursor classes. And you'll also review the basics of interleaving requests. The second module focuses on performing create, read, update, and delete, or CRUD, operations in a MySQL database using Python. You'll start the module by learning how to create and read records in a database. You'll review the steps for this process and discover how Python communicates with a database to carry out these actions. You'll then explore how to perform MySQL update and delete operations using Python. And you'll learn how to commit the changes to the database. You'll then complete this first lesson by performing a series of lab exercises in which you demonstrate your ability to carry out CRUD operations in a MySQL database using Python. In the second lesson of Module 2, you'll review advanced queries in a MySQL database using Python. The first of these queries involves filtering and sorting data in a MySQL database using Python. You'll recap the basics of MySQL filtering and sorting techniques from earlier courses and learn how these same techniques are applied to Python. Next, you'll learn how to perform a range of different join operations to combine data from different tables in a MySQL database using Python. You'll receive an opportunity to test your ability to perform advanced queries in MySQL database using Python through a series of labs. Module 3 focuses on advanced database clients. The first lesson in this module begins with an overview of how to use MySQL functions with Python. You'll begin by learning how to identify the importance of MySQL functions, and you'll review the different types of functions available in MySQL. Once you finish recapping the basics of MySQL functions, you'll then learn how to implement or access MySQL functions using Python. You'll also explore datetime functions in Python and learn how to make use of these functions to update a MySQL database using Python. You'll then demonstrate your ability to make use of these functions in lab exercises. In the second lesson in this third module, you'll explore using MySQL stored procedures with Python. You'll recap the basics of stored procedures, learn how they differ from functions, and how they're created in a MySQL database using Python. You'll then learn how to access stored procedures through Python with the use of the callproc method. And you'll also review the use of delimiters. The third and final module focuses on connection pools. You'll begin by developing an understanding of the concept of database connection pooling. You'll learn how database connection pooling works, and you'll find out how to identify the advantages of database connection pooling. You'll then review the steps for creating a connection pool for a database, including the process for implementing the MySQL connection pool module. You've reached the end of this course introduction. It's now time to begin the next chapter of your database engineering journey. Good luck.
There have been instances in my career where they were interdependent and I had to release them both at the same time. And so the only solution was to release code in the middle of the night when we had the lowest traffic and hope that for the 5 minutes we were down with one while the other one was updating, that only a few users ran into the issue. And sometimes it's the only thing you can do. Hi, my name is Moxie Herrera. I use they, them pronouns, and I'm a software engineer at Meta in the Menlo Park office. I work on donations products, so making sure that we are tracking who is donating to which fundraisers, to which charities. This is very important that we don't get this wrong. We want to make sure that we're storing the right data and getting the right data to display to the right user. And what we mean by that is we want to ensure the data validity. We want to ensure that we are making sure that we are only getting the data that the specific user should see, that we are saving the right data. These are very important concepts when designing a database, that you want it to be reliable. You want to make sure the relationships make sense. And we need to make sure that we're not accessing any data that a specific user shouldn't see. The integrity and quality of a database and its design is one of the first and primary steps to ensuring that our data is protected, our data is being stored in a safe way, and our users can trust that their data is not being mishandled. This requires us to have a well-designed database that is thoughtfully thinking about the different relationships that data can have with each other, as well as having some plan for changes in the future. The process I generally follow when designing a database is to first come up with a core data model that I need for a product to work. I start with that because for me, it's the easiest to conceptualize how we're going to access the data we need from a product perspective. And then after that initial data model is built, I start drilling down into specific privacy and validation uh, details that we need. So should certain data be encrypted? Should certain data be only accessible via certain servers? These are all different questions that we are going to have to ask. And depending on the type of data you store, could be credit card information, could be user information. There's going to be even more checks that you're going to have to integrate into your database and database design in order to accommodate that. The core considerations for a well-designed database at Meta are to first and foremost respect user privacy and user safety. A user should know where their data is and have access to it, and that they should know that it's not being used in any products that they are not comfortable with. The other thing we need to ensure is scalability. Um, it does not matter if you have a really well thought out data model if it cannot scale up with the billions of users that Meta products see every day. I think one of the most common challenges when you're working with a database isn't the initial time you built the database, because you have this concept in your model of a relationship, and then something comes along and changes it. The first thing to do is really be thoughtful about how you can change your database in the future, how it will scale not only with volume of users, but with types of products. The other thing that is very important to think about is how to modify an existing database. This is going to be a very challenging thing, and the majority of the work around databases is a lot of this stuff. We have this old data model, it doesn't suit our needs today. We're going to overcome this, and that requires just a lot of thinking and planning on your part, how to migrate the data. These are big tasks that take time to kind of figure out, but that is some of the ways that you become better at managing database and building better data models in the first place. As a database engineer, you're going to have access to a lot of data, and you really need to keep in mind how integral that is to user trust or the trust of anyone trusting you with this data. Even if you think it's kind of trivial data, there's a lot of trust being put in you to make sure that you're being responsible. I really want you to walk away knowing that database design, database engineering is critical to the overall product experience and integral to user trust in the product that you're building.
Many of the web applications that you use every day rely on a MySQL database to send and store data, and many of these same applications are developed in Python. Database engineers can send and store data from a Python-based application to a MySQL database using a MySQL Python connection. In this video, you'll explore the basics of this important connection and learn how it works. Over at Little Lemon, the restaurant needs to connect a Python application with its MySQL database. They need to form this connection so that they can perform basic MySQL tasks using Python. And they also need your help with these tasks. But first, you need to understand how the connection between MySQL and Python works. So, let's take a few moments to explore the connection between Python and a MySQL database. A connection is established between Python and a MySQL database using an Application Programming Interface, or API. An API is also commonly known as a driver or client. The API is a written set of programs or software that acts as a bridge between the front-end Python application and back-end MySQL database. This connection can be created using different APIs like SQLAlchemy, MySQL Client, and MySQL Connector Python. MySQL Connector Python is the most common API and the one that you'll focus on in this course. A useful way of understanding the connection between MySQL database and Python is visually. Picture a diagram with a Python application on one side and a MySQL database on the other. In between these two elements is the MySQL Connector Python API. In a typical interaction between these elements, the front-end Python application sends a connection request to the Connector API. The connection request is the Python application asking for permission to access and retrieve information from the database using Python. The API forwards the request to the back-end MySQL database. The database accepts the connection. It then sends a message to the Python application back through the API confirming that the connection has been established. In other words, MySQL gives the API permission for the Python application to access the database. Now the Python application sends a connection request to the database. Once the connection is established, you can then instantiate an instance of the cursor from the connector class. And when a cursor object is created, you can then execute SQL queries in the MySQL database using Python. Let's look at Little Lemon's database as an example. Little Lemon need to check what time a guest is arriving for dinner using their Python application. The date and time data for the guest's booking is stored in the backend database. So, the Python application uses the execute module from the cursor object to carry out the customer's demand. The records are returned through the cursor object in the form of tuples that show the booking slots of each guest. Once the request has been fulfilled, the cursor object and database connection can be closed. You should now understand and be able to explain how a connection works between a Python application and a MySQL database. I look forward to teaching you more about the MySQL Python connection in other videos. As a database engineer, you'll frequently work with Python to perform CRUD operations in a MySQL database. But before you can work with Python, you first need to install and configure Python software on your system so that you can create a connection between Python and MySQL. Let's look at the installation and configuration process for creating this connection. The first step is to download the most recent version of Python from the python.org website. Follow the site's installation instructions. Once you've installed Python, you then need to open the application. Select the search icon and access the command prompt. Type python --version to identify which version of Python is running on your machine. If Python is correctly installed, then Python 3 should appear in your console. This means that you are running Python 3. There should also be several numbers after the 3 to indicate which version of Python 3 you are running. Make sure these numbers match the most recent version on the python.org website. If you see a message that states Python not found, then review your Python installation or relevant document on the Python website. Now that you've installed Python, you need to choose an IDE or Integrated Development Environment to run your code on. This is software that you can use to display your code. This course uses the Jupyter IDE to demonstrate Python, so it's probably best if you also use the Jupyter environment. To install Jupyter, type python-m pip install Jupyter. Once Jupyter is installed, type python-m notebook. This opens a new instance of the notebook for you to use within your default browser. Now you can set up your working environment. Select the New button in Jupyter, then choose a new folder. This action generates an unnamed folder. Rename the new folder to MySQL Python Course Content, and then access it. You can now save your projects and other files in this location. Now select New again and choose the Python 3IPY kernel option. This opens a new tab in which you can enter your code. You now need to connect Python to your MySQL database. You can create the installation using a purpose-built Python library called MySQL Connector Python. This library is an API that provides lots of useful features for working with MySQL. The MySQL Connector Python needs to be installed separately using a package installer called pip. The pip package is included with the Python software you just installed. Rename the notebook instance to Configuring MySQL Connector. Now you need to use pip to install the MySQL Connector Python. To install the connector, type an exclamation mark and then pip to call the package. Type the install command, then type the name of the library, which is MySQL-connector-Python. Finally, press Shift and Enter, or select Run to execute the code. The output of this code is that the installation steps have now been performed as required, and a list of libraries have been installed. Python can now access the functionalities of all these libraries. You can import libraries in Python by typing the import command, the name of the library, and an alias. For example, to import MySQL Connector Python in a cell in your Jupyter notebook, just type import mysql.connector as connector. The import syntax tells Python that there is a library you want to import and make use of. The MySQL syntax refers to a subfolder that pip has installed, which hosts the connector. The dot before connector is known as an access operator. It tells Python that you want to access the connector subfolder using the dot operator. Finally, the use of as is a method of renaming the import using aliasing. This is like the aliasing that you encountered in previous database courses when working with joins. Aliasing is a common practice in Python development. You can use custom names, but best practice is to make use of common aliases that other developers are familiar with. Now that you've typed the code, it's time to run it. If there's no output in the console when you run the code, then this means that the connector has been successfully installed. You can now communicate with your database. You should now be familiar with the process of installing MySQL Connector Python to create a bridge between your Python and MySQL environments. And you also know how to install and configure a Python environment. Great work! A Python-based application needs to be able to communicate with MySQL databases to perform database operations. So, this means that you need to create a connection between Python and MySQL. For example, Little Lemon need to create a connection between their website, which relies on Python, and their MySQL database so that customers can view data like menus and booking slots. Let's take a few minutes to find out how a connection is established between Python and MySQL. At this stage, you may be familiar with the MySQL Python Connector API software package. This API facilitates the connection between Python and MySQL. But first, you need to import it into your Python program. To import the connector API, type the import command followed by its name, mysql.connector. Then select Run. However, typing the mysql.connector each time you need to work with the API can be tedious. So, let's create an alias instead. You can create an alias for the mysql.connector called connector. You can then make use of this shorthand to make your coding more efficient. To create an alias, you can type import mysql.connector again or use the existing code. But this time include as connector within your statement. The as keyword instructs Python to recognize import mysql.connector using the connector alias in all future code. Now each time you need to use the MySQL Python connector API, you just type its alias, which is connector. but make sure that you have installed the connector API first. Otherwise, you'll encounter a module not found error. You've now successfully imported the connector API, also called the package or software. Now you can begin to make use of its modules and functionality using the access operator or the dot. For example, you can help Little Lemon to make use of a connector to establish a connection between their Python-based website and MySQL database. First, create a variable to access the connector from the connector module. Call it connection and assign it the value of connector.connect. Next, pass the key arguments to the connect module within a pair of parentheses. These arguments are the database username and password. Only an authorized user can access the database. So, in this instance, the user is Mario and the password is cuisine. By default, a connection is established between Python and the database installed locally on your machine. This database is called localhost. It can also be accessed through its IP of 127.0.0.1. You'll learn more about the localhost and other arguments at a later stage in this course. For now, you should be able to create a connection between Python and MySQL. Nice work. You might be asking yourself, what actions can I take once I've established a connection between a Python client and a MySQL database? Well, some actions you can perform include creating databases and tables. In this video, you'll explore the process for creating databases and tables in a MySQL backend database using Python. Little Lemon uses the MySQL Connector Python client, or API, to communicate with their MySQL database. They need to communicate with the MySQL database to create a database and tables in which they can store data. Let's see if you can help them out. The connection between Little Lemon's existing MySQL databases and their Python application has already been established within a connection object. So, the first step is to create a cursor object that lets you communicate with the MySQL database. You'll learn more about cursors in a later lesson. For now, you just need to know that a cursor object can be created by invoking the cursor module from the connection object. A cursor object points the Python application to the location in the MySQL database where the required data is stored. Once you have a cursor object, you can run queries to the MySQL database. The cursor accesses an execute module that carries the SQL queries as Python strings to the MySQL database. You'll learn more about cursors at a later stage in this course. Now it's time to create a new database. Create a SQL statement as a Python string and pass it to a variable called createDatabaseQuery. The statement must create a database called Little Lemon. You can use triple quotes to change your statement to a Python string. You could also use single quotes to create a string. But the advantage of triple quotes is that you can use them to split a SQL query into multiple lines. And it's much easier to read and manage a SQL query over multiple lines. You now have a SQL query that you can run using the execute method from the cursor. Pass the variable createDatabaseQuery as an argument to the execute method on the cursor object. Execute this code to create the Little Lemon database. Next, you need to set the database for use. The first step is to create your SQL query as a Python string and pass it to a variable called useDatabaseQuery. The query lets you make use of the Little Lemon database through the use command and the name of the database. Then pass the variable as an argument to the execute method. You now have a new database ready to use. The next step is to create tables for the database. Create a variable called createMenuItemTable for your SQL query. Then create your SQL query as a Python string so that you can pass it to the variable. Create the query using the createTable command to create a table called menu items. The columns that Little Lemon need in this table include item ID, name, type, and price. The item ID column must hold the ID for each item on the menu. It's assigned an integer data type and rendered as auto-increment. This means that a new ID is assigned to each item in numeric order. The name and type columns display the name of each item in the menu and the type of cuisine that it's associated with. Both the name and type columns are assigned a data type of varchar and character limits of 200 and 100 respectively. The price column must display the price of each item in the menu. It's assigned an integer data type. The item ID column is assigned the table's primary key. Then execute the Create Menu Item table by invoking the Execute module from the cursor object. You can use this same method to create further tables within the database. Just update your SQL query as needed. Little Lemon now have a new database and table in their MySQL database. And you should now be familiar with the process for creating a database and table in a MySQL backend database using Python while developing a Python-based front-end application. When accessing a MySQL backend database using a Python front-end client, your Python application needs to know where the data required to complete your query is stored. A cursor indicates where this data is positioned on the database. Over the next few minutes, you'll explore the concept of cursors, their key characteristics, and learn how they work. Let's look at an example of cursors from Little Lemon's database. Little Lemon need to retrieve a guest's booking details. They can carry out this task with a SQL select query using Python. However, the Python front-end client needs to know where the data is stored within the back-end MySQL database. The MySQL database can use a cursor object to point to the records that Little Lemon needs. This cursor helps the Python client locate the required data. This example offers a good understanding of what database engineers mean by the term cursors. A cursor is a pointer that directs the Python client to the results of your SQL query within the MySQL database. The cursor indicates the location of the queried data by identifying specific rows or records. You can use a cursor to read, retrieve, and move through individual records within the results of your query. Cursors have several key characteristics or features that are particularly useful to database engineers. For example, cursors are read-only, so you can't update the data that they are associated with. The results can't be modified. They're preserved by the cursor. Cursors are also non-scrollable. They fetch records in order, which helps to keep track of your position when processing individual records. You can't skip or jump between records or fetch them in reverse order. And cursors are also asensitive. This means that they point to the original data within the MySQL database instead of a copy. This is faster than using insensitive cursors, which take longer to return results because they can only point to a copy of the data. So, how can you use a cursor in a MySQL database query? The first step is to declare the cursor. Use the declare statement and assign your cursor a custom name, followed by the cursor keyword. Then use the for keyword and a relevant SQL select statement to determine the purpose of the cursor. Next, you need to open the cursor. Type the open command and call your cursor's name to establish the result set. Now the cursor is pointing to the set of results from your select statement. The next step is to fetch or retrieve the results of your statement. Type the fetch command and the name of your cursor. Then type the into keyword followed by the name of the location the results need to be transferred to. For example, the results can be transferred to a local variable to be used in your Python application. The final step is to close the cursor. Type the close command followed by the cursor name. Closing a cursor is always good practice to release the memory associated with it. As you learned earlier, a cursor is non-scrollable. It works through the results set in order, so once it reaches the last result, it no longer needs to remain open. So, close the cursor to free up the memory it uses. Now that you're familiar with how cursors work, let's return to Little Lemon's query. Little Lemon can use a cursor to retrieve the booking data for their guest. First, they declare a new cursor called Guest Booking Details. This is followed by a SQL select statement that targets the guest's data from the Little Lemon MySQL database. They then open the cursor. Next, they fetch the data and store it in a variable within their Python client called Booking Data. You should now be able to explain what cursors are in a MySQL database, describe their key characteristics, and explain how they work. You'll explore cursors in much more detail as you progress through this course, so this is a great start to your MySQL Python journey. At this stage of the course, you've explored how cursors can be used to point to the location of the data you require in a MySQL database. However, it's also important to understand how Python makes use of the cursor class. The cursor class converts MySQL records to more Python-friendly code. With Python, you can also change or alter the behavior of your cursors using cursor subclasses. In this video, you'll explore the cursor class and subclasses and develop an understanding of how they work. Little Lemon need to find out how much one of their guests spent on their meal. They can query this data from their MySQL database in a more efficient manner by using cursor subclasses to create their Python strings. Let's take a few moments to find out more, starting with building an understanding of what database engineers mean by the term cursor classes. Cursor classes are a method of translating communications between Python and a back-end MySQL database. Python sends SQL statements to a MySQL database in the form of string objects. Cursor classes take these Python string objects and parse them into MySQL-friendly commands and data types that can be understood by the database. Python then uses the cursor class when retrieving these results to parse them into Python-friendly code. The cursor class contains several subclasses which can be used to parse string objects in different ways depending on your needs. At this stage of the course, you may have seen some examples of subclasses in action in the form of attributes and methods. For example, the column names cursor attribute returns the column name of a result set from a SQL statement. Row count returns an integer that represents the number of rows affected by a select, insert, or update statement. Or there's the execute method. The execute method is the most common cursor function. It binds the parameters of a Python string argument to a MySQL query statement so that it can be executed on a MySQL database. Cursor subclasses inherit the properties of the parent cursor class. In turn, the subclasses vary the parent class to improve the efficiency of the code. Let's explore some examples of cursor subclasses. One example is the cursor raw subclass. This subclass returns the results of your variable without pre-processing them to more Python-friendly interpretations. So, it uses less processing power, leaving you free to create custom conversions of the results. However, the disadvantage is that it requires more coding to process the targeted variable. Little Lemon can use the cursor raw subclass to create their own custom data type conversion. This could save time if the initial conversion type is not the one required. Another example of a subclass is the MySQL cursor dictionary class. This returns each row as a dictionary which helps with accessing variables. You can access variables by using direct variable names. Little Lemon can make use of this subclass to return a result set in the form of a dictionary. This lets them use the actual column names of the database columns instead of working through a list of unnamed tuples. And finally, there's the buffered cursor class, which takes a subset of data and stores it in a buffered memory. The advantage to this subclass is that your code doesn't need to repeatedly request each row from the server. The disadvantage is that the data needs to be stored on local memory. So, you can only use this subclass to return small data sets. Little Lemon can use a buffered cursor class to retrieve data. This lets them make interleaving SQL requests. Interleaving of SQL requests is when you take part of a SQL query result and use it to make a subsequent request from a database. Let's take an example where Little Lemon need to find out how much a guest spent on a meal. They can interleave a SQL request to carry out this task. For their first query, they create a MySQL query as a Python string that retrieves the guest's booking ID. Once they have the result of the first query, they then create a second or subsequent query that uses part of the first result, which is the booking ID, to find the cost of the meal. In other words, Little Lemon can use part of their first query within their second query to make a subsequent request from the database. A database can return multiple results from the first query. If you use the first result within your subsequent query before all other results are returned, then MySQL encounters an error called unread result found. So, it's best practice to finish your loop and let all results print from the first query before you make any subsequent queries. However, you can avoid this if you first buffer the results using a buffered cursor. The buffered cursor returns all rows, while a standard cursor requires you to send an individual query to each affected row. Now that you're familiar with the different cursor subclasses, let's look at the syntax for instantiating them. The syntax is very similar across all subclasses. You just pass a keyword argument to the cursor that alters its behavior in a particular way. To create a standard cursor, you create the cursor as an object. So, to instantiate an instance of a cursor subclass, you add the subclass as a keyword argument that alters the behavior of the cursor. For example, you can pass buffered as the keyword to create a buffered cursor, or pass raw as the keyword to create a raw cursor, or dictionary to use a dictionary cursor. Little Lemon can use a cursor subclass to request all data from the orders table in the MySQL database. They can create 2 cursor instances, one buffered and the other a standard implementation. They pass their SQL select statement as an argument to both cursors. Once executed, the cursors return all items from the orders table. You should now understand the concept of cursor subclasses and how they can be used to alter or change the behavior of a cursor. Great work! Congratulations! You've reached the end of the first module in this course. You should now be familiar with the basics of how to interact with a MySQL database using Python. Let's take a moment to recap some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you developed an understanding of how a connection is formed between Python and a MySQL database using an application programming interface, or API, also known as a driver. You now know that a front-end Python application sends a connection request to the connector API. The API forwards this connection to the back-end MySQL database. A cursor connection can then be established. Once the connection is established, data can be sent between Python and MySQL. You also learned about the different APIs that can be used to create this connection, and that, as a database engineer, you'll rely on the MySQL Connector Python API. During this first lesson, you also learned how to install and configure Python software on your system so that you could create a connection between Python and MySQL. You learned how to download Python, make use of pip, and import the different packages that you require. And you also learned how to use aliasing to create custom names to facilitate easier communication with the database. You then explored a working example of how to connect to a MySQL database using a Python client. You saw how the API is imported into a Python program and can be used with an alias. And you now know how to make use of its modules and functionality using the access or dot operator. And you also know how to pass arguments to a connector module like usernames and passwords. You then ended this lesson with an overview of the process for creating tables in a database using Python. You learned that you need to create a cursor object that you can use to communicate with the MySQL database. The cursor object accesses an execute module that carries queries as Python strings to a MySQL database. Once your connections are set up, you can then create data in a MySQL database using Python, like databases and tables. In the final lesson in this module, you learned about cursors. You learned that cursors are used to indicate where data is positioned in a MySQL database so that it can be accessed by a Python client. The cursor lets you read, retrieve, and move through individual records within the results of your query. You then explored the key characteristics or features of cursors that are particularly useful for database engineers. You learned that cursors are read-only, so they can't be modified and preserve results. You discovered that cursors are also non-scrollable. They fetch records in order, which helps you to keep track of your current position when processing individual records. And you also found out that cursors are asensitive. This means that they point to the original data within the MySQL database instead of a copy. You then explored the code required to use a cursor in a MySQL database. You can now use commands like declare to declare a cursor, the open command to call the cursor's name, the fetch command to fetch results, and the close command to close the cursor. You then explored an example of this process from Little Lemon's database. In the next part of this lesson, you explored different cursor subclasses, and you learned how they can be used to change or alter the behavior of your cursors. You discovered that cursor classes are a method of translating communications between Python and a MySQL database. Classes take Python string objects and parse them into MySQL-friendly commands and data types that can be understood by the database. You also explored some common examples of cursor subclasses. Subclasses inherit the properties of their parent cursor class, like the cursor raw subclass, the cursor dictionary subclass, and the buffered cursor class. You also learned about the interleaving SQL requests, which involve taking part of a SQL query to make a subsequent request. You then explored the syntax for creating and using subclasses, and you also explored an example of subclasses from the Little Lemon database. You should now be familiar with the basics of how to interact with a MySQL database using Python, including establishing a MySQL Python connection and working with cursors. Great work! I look forward to guiding you through the next module in which you'll learn how to perform queries in MySQL using Python. As you're aware, working with a database in MySQL involves CRUD operations. Working with databases through Python also involves CRUD operations. The key difference is that the SQL statements used to carry out your operations must be processed in Python as strings. In this video, you'll discover how to execute, create, and read operations in a MySQL database using Python. Little Lemon is populating the restaurant's database with the records of upcoming bookings. Little Lemon also need to retrieve or read this data from their database so they know which guests are attending for dinner. You need to help Little Lemon create and read data in their MySQL database using Python. But first, you need to understand how to create and read data in a MySQL database using Python. Let's get started with creating data. So far, you've learned how to create data in a database using an insert statement, like an insert into command. For example, Little Lemon must use an insert into statement to add the names of customers and the time slots they've booked to the customer name and time columns in a table called bookings in their database. However, there are a few more steps to this approach when working with Python. Create your SQL statement as normal. Then use quotation marks to convert it to a Python string argument. This string argument is passed to a MySQL database through a connector, which parses it into a format that MySQL can understand. So, the first step in the process is to write your SQL statement. Then add a pair of quotation marks to convert it to a Python string argument. Finally, create a variable in which you can store the query as a Python string. Next, Python sends the string to the database through the cursor. The statement is then executed on the database. Little Lemon can use Python to add booking data from guests to their MySQL database using the MySQL insert query variable. The SQL data just needs to be passed in a string format. As you should know by now, you can also retrieve or query data from a database using a select statement. And a SQL select query is also the first step to complete when reading data using Python. Python can read data from a MySQL database using a select statement. And just like with your insert query, you create a variable in which the query can be stored as a Python string, and you write your select query. Make sure that it's written within quotation marks to convert it to a Python string. Little Lemon can use a read data query string object to retrieve all data from their bookings table. They just need to write the select query as a Python string, then use the execute module from the cursor object. Now that you know how to create and read data using Python, let's see if you can help Little Lemon. For the purpose of this demonstration, a connection has already been established between Python, the API, and the MySQL database through the MySQL Connector Python API. So, your first task is to instantiate the cursor object from the connection using the cursor method. The next step is to execute the MySQL insert query by passing it as an argument to the execute method. Once the query is executed, commit the change to the database using the commit method of the connection object. Now, each new instance of customer data is added to the bookings table in the database through the MySQL insert query. For the next stage of development, Little Lemon needs to read or retrieve the data in their database. Some sample customer data has been added to the database to test the read functionality. You need to develop the functionality and retrieve this data. As you learned earlier, the first step is to create a SQL statement as a Python string that you can pass to a variable. In this case, you need to create a SQL select statement that retrieves all data from the bookings table in the database, and pass this statement as a string to the Python variable called readDataQuery. Now you need to pass your query to the execute module on the cursor, just like you did when creating data. Once the query is executed, you need to retrieve the results using the fetchAll method on the cursor. Create a new variable called results, then pass the results of your query to this variable through the cursor object. The results variable is a list data type, and it shows each record in the form of a tuple. So, the results variable is essentially a list of tuples, and each tuple is a single extracted row from the bookings table. In this instance, the items in each tuple in the results variable are ordered in the same way as the columns in the bookings table. They are ordered this way because you're reading all records from the table. You can retrieve the column names by creating a new variable named columns and calling the column names from the cursor object. These values are then stored in the columns variable for later use. Don't forget that it's also good practice to close the cursor object and connection when you no longer need them. You now know how to execute create and read operations in a back-end MySQL database using a front-end Python application. That's a great start. I look forward to guiding you through more CRUD operations in Python. Updating and deleting records in a MySQL database involves routine CRUD operations. They're also common operations for a Python-based application that interacts with the MySQL database. Over the next few minutes, you'll learn how to execute update and delete operations in a back-end MySQL database using Python. Little Lemon needs to update and delete the records of the restaurant guests in the bookings table in their database using Python. You need to help Little Lemon with this task. But first, let's take a quick look at the bookings table. This table holds the booking data of each guest. This includes their booking ID, table number, first and last name, booking slot, and the ID of their waiter. Little Lemon must update and delete data within this table using Python. Let's begin with updating records. As you know from previous courses, data is updated in a database using update statements. Little Lemon needs to update the booking data of a guest. Let's see if you can help them out. You can start by writing a SQL update query that uses a where clause to let Little Lemon update a guest's table number. The update query is created as a string. It's then passed to a string object called updateBookings. Little Lemon just needs to update the specific values of each query. Let's test this query by updating the booking information for guest 6, Diana Pinto, who has been moved to table 10. Use the execute method to run the query and update the records in the bookings table in the database. To commit these changes to the table in the database, use the commit method. To check that the data was updated correctly, you can run the print cells of the Jupyter Notebook. The guest with the booking ID of 6 is now assigned to table 10. The update query has worked. There are also times when guests cancel their bookings. When this happens, Little Lemon needs to delete their records from the database. To carry out this task, write a SQL delete statement that deletes the record of a specific guest from the bookings table. Your statement can use a where clause of booking ID. The delete statement is created as a Python string. It's then assigned to a string object called deleteBookingID. You can test this query by deleting the booking information for Marcos Romero, who was assigned the booking ID of 4. Use the execute method to run the query. Then commit the changes to the database. Now it's time to check that the query worked with another printout. You can rerun the cells with the initial select query from the Jupyter Notebook. The printout changes if the database has been altered. There's no data in the table for Marcos Romero. This means that your delete statement was successful. You can also amend the where clause in your delete statement to check for null values next to table and employee IDs. If the value is null, then you can set the bookings to be deleted. You now know how to perform update and delete operations in a MySQL database using Python. Great work! When you query records in a database, your query can often return hundreds, thousands, or even millions of results, depending on how much data there is. But you might only require a fraction of these results. As you saw in earlier courses, you can use filtering and sorting techniques to target only the data you need from these results. When querying a MySQL database using Python, you can apply these same techniques to ensure that your query targets specific data. Over the next few minutes, you'll recap some basic filtering and sorting techniques and learn how to filter and sort MySQL data using Python. Over at Little Lemon, the restaurant is currently querying the bill records of each customer in its database. They need the records of all bookings with a final bill greater than or equal to $40. They also need the bookings to appear in ascending order with respect to the total bill amount. Filtering and sorting techniques are a great way to carry out this task. Let's find out how these techniques work with Python and then help Little Lemon. One filtering technique that you should be familiar with is the use of the where clause. Let's begin with a quick recap of the where clause. As you should know by now, you can use this clause to filter and extract records that satisfy a specific condition. For example, Little Lemon can use the where clause to create a SQLSelect statement that targets the booking ID and bill amount columns in their orders table. The statement returns all values in the bill amount column equal to a value of 40. The where clause helps to filter the records from the database, but not to the extent that Little Lemon require. As you saw earlier, Little Lemon need the records of all bookings with a final bill greater than or equal to $40. You can use comparison operators to specify the exact data you require from a database. For example, Little Lemon can replace the equals operator in their statement with the greater than or equals to comparison operator. This operator targets all records from a database where the bill amount is greater than or equal to a value of 40. This narrows down the records even further, returning much more specific results. Another technique is the order by clause. As you should know, the order by clause is an optional clause that can be added to a SQLSelect statement. It helps to sort data in ascending or descending order. So, to filter their records even more efficiently, Little Lemon can add the order by clause to the end of their statement. They target the bill amount column and then type the ascending keyword. Once executed, the query returns all bill amounts greater than or equal to $40 in ascending order. Now that you've recapped some examples of filtering and sorting techniques, your next question might be, how can I use these techniques in Python to query a MySQL database? Well, as you saw earlier, Little Lemon need to query the records in their MySQL database using Python. Let's help them create this query using the filtering and sorting techniques that you just explored. To recap, Little Lemon need the records of all bookings with a final bill greater than or equal to $40. They also need the bookings to appear in ascending order with respect to the total bill amount. First, write a SQLSelect query as a Python string stored in a variable called MySQL query. The query must target the booking ID and bill amount columns from the orders table. Use the where clause and a greater than or equal to comparison operator to target all records that are greater than or equal to the value of 40. Then use the order by clause and the ascending keyword to order all records from the bill amount column in ascending order. The next step is to establish a connection through the MySQL Connector Python API between the front-end Python application and the back-end MySQL database. Then get the cursor object from the connection using the cursor method. Run the query using the execute method from the cursor object. Once the query is successfully executed, you can fetch all the results in a new variable called results that satisfies the conditions given in your query. Just use the fetchAll method on the cursor object to grab the query results. All the retrieved data is in results as a Python list of tuples. You can display the list on your dashboard for Little Lemon. Little Lemon now have the data they need, and you should now be able to explain how to make use of filtering and sorting techniques to target records in a MySQL database using Python. Great work! At this stage of your database engineering journey, you should have experience of using join operations to extract data from multiple tables. There are also instances in which you'll need to perform a join operation on a MySQL database using Python. In this video, you'll explore the process for executing join operations using Python. Little Lemon are adding a new menu feature to their website. This feature lets customers view menu items, their prices, and the type of cuisine each meal is related to. The data that the feature requires is in two different tables in their MySQL database: menu and menu items. Little Lemon need to use a join to combine the data from these tables to create their menu feature. Let's quickly recap the concept of a join. A join is created using the SQL join clause. It targets a common column between the two target tables. These common columns are used to join the tables together and extract the required records. Some examples of joins used in MySQL include left join, right join, inner join, and outer join. All these joins can be used with Python. Let's explore an example of the syntax and process for creating an inner join. First, a SQL query is created using join as a Python string that can be passed to a variable. The query is then run using the execute method from the cursor object. Once the query is executed, you can retrieve its results into another variable. Use the fetchAll method on the cursor object that holds the results of the join. The data is retrieved as a list of tuples. For example, Little Lemon can create a join query as a string object in Python that combines the menu items and menu tables. This join is performed using an inner join on the item ID column, which is common to both tables. When executed using Python on a MySQL database, this statement returns all required results. Now that you're familiar with the process for joining data from different tables using Python, let's see if you can help Little Lemon to create this query. As you learned earlier, Little Lemon need to use a join query to extract the data for the new menu feature on their website. They begin by creating the join statement as a string object in Python. Store it in a variable called myJoinQuery. The join query must target the name, type, and price columns from the menu items table, and it must also target the cuisine column from the menu table. An inner join is created on the item ID column, which is common to both tables. Let's assume that the MySQL Connector Python API is running a connection between the front and back end, and that the cursor object is also available. This means that you can now execute your query using the join statement. Run the query using the execute method from the cursor object. When the query is executed, you can fetch all the results from the cursor object in a new variable called results using the fetchAll method. The results are retrieved as a list of tuples, one for each row. Little Lemon can view the order of each individual entry. They just call the column names attribute on the cursor to return the names of the column in order. At this stage of your database engineering journey, you should have experience of using joins to extract data from multiple tables. And you should now be familiar with extracting data from a MySQL database using joins in Python. Well done! Congratulations! You've reached the end of the second module in this course. You should now be familiar with how to perform queries in a MySQL database using Python. Let's take a few moments to recap some of the key skills that you've gained in this module's lessons. In the first lesson, you learned how to perform create, read, update, and delete, or CRUD operations in a MySQL database using Python. You started this lesson with a recap of how to create data in a MySQL database using an insert statement. You then learned how data is inserted into a MySQL database using Python. First, it's created as a Python string argument. This argument is then passed to a MySQL database using a connector. The connector parses it into a format that MySQL can understand. You then explored an example of the syntax used to render a MySQL database query as a Python string argument. And you explored an example of creating and reading data using Python from the Little Lemon database. Next, you recapped how to delete and update records in a MySQL database using update and delete operations. You learned how to create these queries as Python string arguments, and explored some examples from the Little Lemon database. You then undertook a series of lab exercises in which you received the opportunity to perform CRUD operations in your own MySQL database using Python. And you tested your knowledge of these topics by completing several quizzes. In the second lesson of this module, you learned how to perform advanced queries in a MySQL database using Python. You began the lesson by learning how to filter and sort records in MySQL using Python. You recapped the basic filtering and sorting techniques that you learned in other courses. These include the use of the where clause to satisfy one or more specific conditions, utilizing the order by clause to sort data in ascending or descending order, and the inclusion of comparison operators to specify the exact data required. You then discovered how these techniques are used in Python by exploring several examples from the Little Lemon database. The next part of this lesson focused on joining data from different tables in a MySQL database using Python. You recapped the basics of the join clause and how it can be used to target a common column between two target tables. You then learned how join can be used with Python to extract data from a MySQL database. A SQL query is created using join as a Python string. The string is executed using the execute module on the cursor object. The results are then retrieved from the MySQL database using another variable that satisfies the query's conditions and the fetchAll method. You also explored an example of this process from the Little Lemon database. And, just like the first lesson, you also completed a lab exercise. In this lab exercise, you performed a join operation using Python to extract data from a MySQL database. You then tested your knowledge of the process in a quiz. You should now be equipped with the skills and knowledge required to perform queries in a MySQL database using Python. Well done! I look forward to guiding you through the next module, in which you'll explore the topic of advanced database clients. There are many different types of tasks that you need to perform when working with a MySQL database. Functions are a great way to store the syntax that you need for these tasks as reusable blocks of code. These code blocks mean that you don't have to retype your code each time you need to use it. Over the next few minutes, you'll recap the basics of functions and learn how they're used with Python. Little Lemon's MySQL database holds a lot of data on different aspects of the company, like customer behavior and sales revenue. Little Lemon can use functions to perform specific operations on their database and return results. They can then use the data from these results to improve the restaurant's performance. So, let's quickly recap the basics of MySQL functions. As you probably already know, a MySQL function is a piece of code that performs a specific operation and returns a result. In other words, it's a task that combines a set of instructions and produces results in the form of an output. MySQL functions provide a lot of advantages for database engineers. Some MySQL functions accept parameters or arguments, while others don't. They're great for manipulating data in a database. You can also create custom functions that combine several tasks in a block of code. You can then store these functions within your database and invoke them when needed. And, as you've just discovered, MySQL functions are reusable, so they can be used to complete repeat tasks. At this stage of your database engineering journey, you've probably made use of many different types of functions. The most common built-in functions available in MySQL include string functions, numeric functions, and date and time functions. There's also comparison and control flow functions. Let's take a moment to recap the basics of these different types of functions and look at how Little Lemon can make use of them. Let's begin with string functions. These functions are used to manipulate string values, like adding strings together or extracting a segment of a string. An example of a string function is concat. Concat combines data from two separate tables into one string. Little Lemon can use a concat string query function on their database records to extract information on each customer, like how much money they spent. You can also use numeric functions in MySQL. Numeric functions include aggregate and math functions. These functions are used to carry out common tasks on numeric datasets. For example, Little Lemon can use the average numeric function to determine the average dollar amount that each customer spends with the business. Another example of MySQL functions includes date and time functions. Date and time functions can be used to query a MySQL database to extract date and time values in a range of different formats, depending on the query. Over at Little Lemon, they often extract date and time data to analyze the behavior of their customers. They can use this data to find out how long guests spend at the restaurant and which days are the busiest. Next up is comparison functions. You can use these functions to compare values within a database, and they can be used with many different types of values, like numerical, strings, and characters. Little Lemon make use of comparison functions to identify the best and lowest selling items on their menu by using greatest and least comparison functions on their sales data. And finally, there's control flow functions. Control flow functions are used to evaluate conditions and determine the execution path or flow of a query. For example, as you learned previously, the case function runs through a set of conditions within a case block. It then returns a value once a condition is met, or a null value if no conditions are met. Little Lemon often rely on control flow functions to determine which items on their menu are loss-making and which items have turned a profit. Now that you've recapped the different functions available in MySQL, let's find out how they work with Python. Let's take the example of numeric functions and see how Little Lemon calculate the mean or average bill for each customer. They can create a select query that uses the average function to determine the average bill amount. This query is passed to the database to be executed. Once the query is executed, Little Lemon can access the results and see the average dollar amount each client spent with the business. This is just a basic recap of MySQL functions and a short demonstration of how they work in Python. The rest of this lesson will explore methods for accessing MySQL functions using Python in more detail. I'm looking forward to exploring this topic in more detail with you. As a database engineer, you can use date and time functions to extract time and date values from a database. And you can perform similar tasks using the functions available in Python's native datetime library. In this video, you'll learn about the different date-time functions available in Python and how you can make use of them. Little Lemon has received several bookings from guests for tonight. However, the restaurant has encountered a scheduling conflict, so they need to push each booking slot forward by 1 hour. Python's date-time functions are a great way to solve this problem. Find out how date-time functions work, then help Little Lemon to update their booking slots. Let's begin with an overview of datetime. Datetime is a Python class with several built-in functions that can be used to format and change time and date variables. It's native to Python, so you can import it without requiring pip. Let's review the functions that Python's datetime library offers. The datetime_now function is used to retrieve today's date. You can also use datetime_date to retrieve just the date, or datetime_time to call the current time. And the time_delta function calculates the difference between two values. Now let's look at the syntax for implementing datetime. To import the datetime Python class, use the import code followed by the library name. Then use the as keyword to create an alias of dt. You can now use this alias to call the library instead of typing datetime every time you need to use a function. You now have a datetime object created within your Python environment. So, let's find out how to make use of its functionality using the dateTimeNow function. Begin by creating a variable called currentTime. Next, type the DT alias as the module name. Then use it to call the dateTimeNow function. Finally, instruct Python to print the current date and time values. Execute the code to print the time and date of your location. Python returns the date and then the time. The date is displayed in year, month, day format. The time is displayed in hours, minutes, seconds format. But what if you just need to know the current time? Or maybe you just want today's date? You can use the same code again, but this time give Python two separate print instructions. The first instruction tells Python to print the current date, and the second instruction tells Python to print the current time. When the code is executed, Python displays each value separately. Let's look at a slightly more complex function, time delta. When making plans, it can be useful to project into the future. For example, what date is this same day next week? You can answer questions like this using the time delta function to calculate the difference between two values and return the result in a Python-friendly format. So, to find the date in 7 days' time, you can create a new variable called week. Type the DT module and access the time delta function as an object instance. Then pass through 7 days as an argument. Finally, instruct Python to print the results of the variable. When executed, Python returns the value of the date 1 week from now. Now that you know how datetime works, let's see if you can help Little Lemon. As you learned earlier, Little Lemon have encountered a scheduling conflict. To resolve it, they need to push each booking slot forward by 1 hour. You can carry out this task by instructing Python to retrieve the data from the bookings table and then adding 1 hour to each booking. Let's assume that Little Lemon have already passed through their login details, created a new cursor instance, and pointed the cursor at their database. Your first task is now to import the datetime library so that you can work with datetime. Use the import keyword and import the library using the alias DT. This alias is used for greater efficiency. Next, write a SQL select statement to return all data from the bookings table. Pass the statement to the execute module from the cursor as a string argument. Before entering the loop, instruct Python to print the column names from the bookings table so that you can view each item in the row. You can assign these values to variables and create a new variable called newBookingSlot that holds the values for the updated time slots. To add an hour to each time slot, pass an argument of 1 hour to the time delta function, and then add the function to the booking slot variable. Finally, instruct Python to print the values for the new booking slots in the form of a text string. This text string details the values of each booking ID along with its respective old and new booking slots. Loop through the results from the query and extract the rows from the booking ID and booking slot columns. As the results show, booking ID is the first value and booking slot is the fourth value. You should now be familiar with the different datetime functions available in Python and how you can make use of them. Working with datetime functions can be difficult, but you've made a great start towards mastering this topic. As a database engineer, you can use date and time functions to extract time and date values from a database. And you can perform similar tasks using the functions available in Python's native datetime library. In this video, you'll learn about the different datetime functions available in Python and how you can make use of them. Little Lemon has received several bookings from guests for tonight. However, the restaurant has encountered a scheduling conflict. So they need to push each booking slot forward by 1 hour. Python's datetime functions are a great way to solve this problem. Find out how datetime functions work, then help Little Lemon to update their booking slots. Let's begin with an overview of datetime. Datetime is a Python class with several built-in functions that can be used to format and change time and date variables. It's native to Python, so you can import it without requiring pip. Let's review the functions that Python's datetime library offers. The datetime_now function is used to retrieve today's date. You can also use datetime_date to retrieve just the date, or datetime_time to call the current time. And the time_delta function calculates the difference between two values. Now let's look at the syntax for implementing datetime. To import the datetime Python class, use the import code followed by the library name. Then use the as keyword to create an alias of dt. You can now use this alias to call the library instead of typing datetime every time you need to use a function. You now have a datetime object created within your Python environment. So, let's find out how to make use of its functionality using the datetime_now function. Begin by creating a variable called currentTime. Next, type the dt alias as the module name. Then use it to call the datetime_now function. Finally, instruct Python to print the current date and time values. Execute the code to print the time and date of your location. Python returns the date and then the time. The date is displayed in year, month, day format. The time is displayed in hours, minutes, seconds format. But what if you just need to know the current time? Or maybe you just want today's date? You can use the same code again, but this time give Python two separate print instructions. The first instruction tells Python to print the current date, and the second instruction tells Python to print the current time. When the code is executed, Python displays each value separately. Let's look at a slightly more complex function, time_delta. When making plans, it can be useful to project into the future. For example, what date is this same day next week? You can answer questions like this using the time_delta function to calculate the difference between two values and return the result in a Python-friendly format. So, to find the date in 7 days' time, you can create a new variable called week. Type the dt module and access the time_delta function as an object instance. Then pass through 7 days as an argument. Finally, instruct Python to print the results of the variable. When executed, Python returns the value of the date 1 week from now. Now that you know how datetime works, let's see if you can help Little Lemon. As you learned earlier, Little Lemon have encountered a scheduling conflict. To resolve it, they need to push each booking slot forward by 1 hour. You can carry out this task by instructing Python to retrieve the data from the bookings table and then adding 1 hour to each booking. Begin by creating a connection between the front-end Python client and the back-end database. Then pass through your login details. This creates a new cursor instance and points the cursor at the Little Lemon database. Before you can begin working with datetime, you first need to import the datetime library. Use the import keyword and import the library using the alias dt. This alias is used for greater efficiency. Next, write a SQL select statement to return all data from the bookings table. Pass the statement to the execute module from the cursor as a string argument. Before entering the loop, instruct Python to print the column names from the bookings table so that you can view each item in the row. You can assign these values to variables and create a new variable called newBookingSlot that holds the values for the updated time slots. To add an hour to each time slot, pass an argument of 1 hour to the time_delta function, and then add the function to the booking slot variable. Finally, instruct Python to print the values for the new booking slots in the form of a text string. This text string details the values of each booking ID along with its respective old and new booking slots. Loop through the results from the query and extract the rows from the booking ID and booking slot columns. As the results show, booking ID is the first value and booking slot is the fourth value. You should now be familiar with the different datetime functions available in Python and how you can make use of them. Working with datetime functions can be difficult, but you've made a great start towards mastering this topic. Stored procedures provide database engineers with a useful way of storing and recalling code when needed. Over the next few minutes, you'll receive a quick recap of MySQL stored procedures and how they work. Let's begin with a look at how stored procedures can help Little Lemon. Little Lemon checks the online bookings in its database every morning for a list of customers attending the restaurant that day. They rewrite the same code each morning to extract this data. But they could instead invoke a stored procedure that extracts the required data without the need to rewrite large blocks of code every morning. Before you find out how they can do this, let's recap the basics of stored procedures. A stored procedure is a block of code, or one or more pre-prepared queries that can be stored in your database. You can then invoke or call the stored procedure as required. As you might already know, this is similar to how a function works, but don't forget the key difference between the two concepts. Functions can only have input parameters, but a stored procedure can have both input and output parameters. There are 3 main steps to complete when using stored procedures. You should already be familiar with these. First, you create a stored procedure, then you call a stored procedure, and finally, you can drop or delete a stored procedure. Let's begin with a recap of the benefits of stored procedures. Your code is more consistent. The same code block is used each time it's invoked. You know exactly what to expect from it. Your code is reusable. You can use it as many times as you need across all your database tasks. And your code is easier to use and maintain. It's stored as one block that can be invoked, edited, or dropped as required. Next, let's quickly recap the syntax for creating a stored procedure. To create a stored procedure, begin with the create procedure command. Then write the procedure name and a pair of parentheses to hold the parameters. Make sure that you include all required parameters within the parentheses. Finally, write the rest of the procedure logic. Then, when you need to invoke the procedure, you just type the call command followed by the procedure name. Don't forget to include the parentheses. And if you need to remove or drop a stored procedure from your database, then just type the drop procedure command followed by the procedure name. In this instance, you don't need to include any parentheses. Little Lemon can use this code to create a stored procedure that extracts the details of the customers due to visit the restaurant. They begin with the create procedure command. Then they name the procedure daily_customer_details and add the parameters. Finally, they write the logic of the procedure. Now, each morning, they just need to type the call command followed by daily_customer_details. The stored procedure then extracts the required customer data from the database. So, now that you've recapped the concept of stored procedures, you might be asking yourself, how do stored procedures relate to Python? Stored procedures increase the performance of Python applications and reduce traffic between the application and the MySQL database. The application only needs to send the name of the stored procedure and parameter to the database, instead of a large block of SQL statements. You're now familiar with the benefits of stored procedures and how to create, invoke, and drop them in a database. You're now ready to learn how to perform these actions using Python. Great work! You should be familiar with creating stored procedures in a MySQL database, but how can you make use of stored procedures using Python? In this video, you'll learn how to access stored procedures using Python. Little Lemon Restaurant have a new promotional campaign where they give vouchers to all guests who spend $50 or more on a meal. To find out which guests qualify for vouchers, the team need to retrieve the guest names, booking IDs, and bill amount data from the bookings and orders tables in the database. You can complete this task using a join operation, but performing a separate join operation for each guest is time-consuming. A better solution for Little Lemon is to create a stored procedure they can call using Python. Let's see if you can help Little Lemon to build a stored procedure using Python. The first step is to create the stored procedure as a Python string stored in a variable called stored procedure query. Next, type the create procedure command and then the name of your procedure, which is get customers and bills. Then create a begin-end block. Type the logic of your stored procedure within this block using a SQL select statement. The statement concatenates the required data from both tables with the use of an inner join for all customers who've spent $50 or more. Don't worry about setting the delimiter before and after the procedure. The cursor executes the entire Python string as one MySQL statement. So, unlike with a traditional MySQL query, there's no need for a delimiter. In Python, the stored procedure is passed as a single Python string. It can also include multiple SQL statements. When executing MySQL statements through an API, the required closing semicolon is automatically appended to the end of the string. When executing a stored procedure, you need to store a block of code on the MySQL database that you can invoke when required. You can trigger this block with the cursor callProcedure or callProc method. The cursor carries the stored procedure as a string in its execute module and stores it in the MySQL database. You are now ready to execute the stored procedure statement and store it on the MySQL database using Python. Call the execute method from the cursor object and pass the procedure to it as an argument. If executed successfully, the procedure is stored in the MySQL database. Now you can call this procedure. First, you need to call or invoke the procedure. You can do this using the cursor object's callProc method. Pass the name of the procedure to the module on the cursor object as an argument. Next, you need to retrieve the procedure's results. You can make use of Python's built-in next function to complete this task. Invoke the stored results module as an argument to the next function and store them as a Python variable called results. The next function is used to return the next item from the stored results iterator. The entire result set from the MySQL server is then buffered in the results variable. Now you can invoke the fetchAll method on the results variable and save it as dataset. Once the code has been run successfully, the dataset returns a Python list of tuples. Each tuple is an individual record or row from the stored procedure. You can index the dataset or run the for loop to print all records. The results of the procedure show that there is one guest who has spent $50 or more with Little Lemon and qualifies for vouchers. You now know how to access stored procedures using Python. Great work! A MySQL database needs to provide access to many users at once, and each connection must be secure and stable so that only authenticated users can gain access and there's no risk of their connections failing. But managing secure and stable connections requires many resource-heavy actions. So how can you perform these actions efficiently? The answer lies in database connection pooling. In this video, you'll explore the concept of database connection pooling, investigate how it works, and learn about its advantages. Little Lemon's website has a Python-based application that lets guests book time slots with the restaurant. The application sends the guests' bookings as SQL statements to the Little Lemon database. However, the website needs to provide each guest with a secure and stable connection to the Little Lemon database. This is so that they can input their booking data without any risk of connection failure. Little Lemon can manage these connections with the use of database connection pooling. Let's find out more. Database connection pooling involves creating and managing a pool of connections to run faster, more efficient, and optimized connections between clients and a MySQL database. To gain a better understanding of how connection pooling works, let's explore a visual example. Visualize a pool of 4 open connections to a MySQL database. 2 of the connections are currently being used by clients to access the database. The other 2 connections are free and ready to use by any new user. A new user can arrive and request access to the database. The connection pool then assigns this new user one of the open connections. Shortly after the new user is assigned their connection, the first 2 users complete their tasks, end their sessions, and leave the pool. Even though the users have left the pool, the connections remain open. Technically speaking, the connections aren't closed. They're just placed back in the connection pool where they remain available for new users. There are now 3 free and ready-to-use connections that can be assigned to new users. But what if all 4 connections are in use and a 5th user wants to join? There are only 4 connections available. So how can you serve the fifth user's access request? To avoid this situation, the best approach is to create multiple pools with a specific number of connections assigned to each pool. This means that different users can be assigned to different pools. So, there's always an available connection in at least one pool for new users. You can also program the system to create a new connection within a pool if an appropriate connection isn't available in other pools. Little Lemon can use this approach to manage connections to their MySQL database. They can create a series of connection pools that their guests can use to record their bookings in the database. There are a few key advantages to connection pooling. Connection pooling makes efficient use of available resources. It reduces the time and effort required to establish connections. Connection pools simplify programming models, and they increase the performance of the Python application when connecting to the MySQL database. You should now be familiar with the concept of database connection pooling, be able to explain how it works, and to describe its advantages. There's lots more to learn about connection pooling in this lesson, but you're off to a great start. Database connection pools are a great way of providing secure, authenticated connections to a database for multiple users. And the MySQL Connector Python API provides a useful method for developing connection pools in the form of the MySQL Connection Pool module. In this video, you'll learn how to create a connection pool for a database using the MySQL Connection Pool module. Little Lemon need to provide secure, authenticated connections to their database for their team of web developers. They've decided that the most efficient way of providing these connections is through connection pooling. Let's take a few minutes to find out how to build a connection pool. Then use your new skills to help Little Lemon build a secure connection pool. A database connection pool is managed and maintained using a module called MySQL Connection Pool. The module is held in a directory called mysql.connector.pooling. You can import the module into your working environment and access its functionality using the import syntax. And the from keyword is used to identify the module's location. In other words, the code is instructing Python to access the subdirectory and return the MySQL Connection Pool library. The MySQL Connection Pool module has many useful functions and attributes that you can make use of. Let's look at a few of these. The pool name class attribute is used to identify the name of the pool to be used in the connection. If you don't specify a pool, then one is automatically generated instead. You can create as many pools as you need. The pool size attribute states the number of connections that have been created for a pool. The default number of connections is 5, but you can create up to 32 connections for a single pool. And finally, there's the connection ID attribute. This is a unique ID assigned to each connection in the pool. There are also many class methods available in the MySQL Connection Pool module. You can use the getConnection method to request a connection. The pool then assigns a free connection if one is available. If no connection is available, then you'll receive a pool exhausted error instead. The isConnected method is a Boolean function that returns either a true or false value depending on whether a connection has been made. This is a useful way of avoiding errors. Finally, the close method informs the connection pool that a user has completed their session. The user no longer needs the connection, so the connection can be placed back into the pool as an available connection for any new users who need it. Now that you're familiar with the module connection pool, let's see if you can help Little Lemon. As you learned earlier, Little Lemon want to create a connection pool to provide users with efficient access to their database. Before you can create a connection pool, you first need to import the MySQL Connection Pool library using the MySQL Connector Python API. Once you've imported the connector, the next step is to make a connection to the database. Call the pool Little Lemon Pool, then use the pool size attribute to specify 4 connections. Use the local host as your host and place the pool on the Little Lemon database. Then type the username and password. All this code is passed as arguments or parameters to the MySQL Connection Pool module and assigned to the pool. Next, you need to create a Python list of users for the connection pool. You can call this list users. Populate the list with members of Little Lemon's guest list. You then need to create a SQL select statement. This statement must accept an integer. The integer must correspond with different ID requests accessing different data points as database users. Now you need to use the for loop. You can use it with the range function. The range function is used with the pool size attribute. This means that no matter how big the pool is, the loop always runs to the end. The next step is to set up the application's connection. Write a statement that checks if a connection was successfully made within the pool. This statement also avoids any errors appearing in your code. Then write a statement that instantiates a new cursor from the existing active pool connections. This action must occur for each new live connection that's successfully made with the pool. Next, create a print statement that displays the following information on screen: the user requesting information from the database, the unique connection assigned to this user, and the unique booking ID that they're requesting. The print statement is formatted using curly braces. These symbols take the specified variables in the order that they are specified from the format function. So, this means that the information is printed in the order you specify. The next line of your code is a parameterized select statement. This statement uses the initial SQL select statement from earlier and combines it with the incremented I to assign a different booking ID to each user. Then you can use the fetchAll method to return all information that corresponds with this SQL select statement and print the information on screen. You can also create an else statement that generates an error message on screen if a live connection cannot be found. Finally, use the close method to return a user's connection back to the pool when they have ended their session. You should now know how to create a connection pool for a database using the functions and attributes available with the MySQL Connection Pool module. Congratulations! You've reached the end of the third module in this course. You should now be familiar with how to make use of functions and stored procedures in a MySQL database using Python, along with creating and managing database connection pools. Let's take a few moments to recap some of the key skills that you've gained in this module's lessons. In the first lesson of this module, you learned how to make use of MySQL functions using Python. You began with a quick review of MySQL functions by reminding yourself of the advantages that functions offer. Their main advantage is that they eliminate the need to carry out repetitive tasks. You also familiarized yourself with many of the common MySQL functions that you explored in earlier courses. These included string, numeric, and date and time functions, as well as comparison and control flow functions. You recapped how string functions are used to manipulate string values. You learned how to make use of numeric functions to perform tasks on numeric datasets. You saw how you can extract date and time values from a database using date and time functions. You received a reminder of how to compare values within a database using comparison functions. And you reviewed the process steps for using control flow functions to evaluate conditions and determine the execution path or flow of a query. You then learned how to access MySQL functions using Python by exploring examples from the Little Lemon database. And you also demonstrated your new skills and knowledge in the lab and quiz activities. In the second lesson of this module, you recapped the basics of stored procedures. You learned once again that a stored procedure is a block of code that can be stored in your database and invoked as required. Stored procedures offer several advantages, like consistent code, reusable code, and the ability to maintain code as one single block. You then recapped the syntax used to create stored procedures, including the create procedure, call, and drop procedure commands, and the begin-end block. And you examined the advantages of using stored procedures with Python. You saw that they increase the performance of Python and reduce traffic between Python and MySQL. In the next item in this lesson, you learned how to access stored procedures using Python. You explored some examples of stored procedures from Little Lemon, like the inner join operation. You saw how they made use of these stored procedures in Python to query a MySQL database. You also learned how to call or invoke a procedure in Python using the callProc method, retrieving results using Python's next function. And you saw an example of the use of fetchAll method. Once a stored procedure has been successfully run using Python, the data is returned as a list of tuples. You can index the dataset or run the for loop to print all records. You then demonstrated your ability to use stored procedures in Python in a lab environment. And you tested your knowledge of Python and stored procedures in a quiz. In the third and final lesson of this module, you learned about connection pools. During this review, you learned that connection pools are resource efficient, provide faster connectivity, simplify programming models, and increase the performance of Python applications. You then learned about Python MySQL connection pools. You learned that a database connection pool is managed and maintained using a MySQL connection pool module. This module is imported into your working environment so that you can access its functionality. The module also offers many useful functions and attributes that you can make use of. This includes pool name, pool size, and connection ID. And there are also several class methods available like getConnection, isConnected, and close. These methods are useful for managing and maintaining the module. You then explored an example of how to create a MySQL connection pool using the MySQL Connector Python API. You also explored the concept of database connection pooling. You learned that database connection pooling involves creating and managing a pool of connections to run faster, more efficient, and optimized connections between clients and a MySQL database. Connections are managed between clients, and users can drop in and out of sessions by using active connections. And you can create multiple pools with specific numbers of connections so that there's always an available connection for every user. You then completed a lab in which you worked with connection pools, and you tested your knowledge of connection pools in a quiz. You should now be equipped with the skills and knowledge required to work with MySQL functions and stored procedures using Python, and you should also now be able to create and manage database connection pools. Well done! I look forward to guiding you through the next module in which you'll work with a database client. In this course, you learned about database clients. Let's take a few moments to recap the key lessons that you encountered in this course. You started the module by learning about the MySQL Connector Python API and how to make use of the pip package. You then learned how to install a front-end Python client and connect it to a back-end MySQL database. You then explored how to establish communication between Python and MySQL to perform CRUD operations. Once you established a connection, you then accessed a cursor object. Once you had access to the cursor object, you created a MySQL database and table using Python. You then committed changes in a MySQL database using Python. In the third and final lesson of Module 1, you explored the concept of cursors in a MySQL database. You learned how cursors work in Python and MySQL. You also reviewed the key characteristics of cursors and learned that they're read-only, non-scrollable, and asensitive. You then learned that the cursor class is used to translate communication between Python and a MySQL database. And you also learned how to identify different cursor classes. And you also reviewed the basics of interleaving requests. The second module focused on performing create, read, update, and delete, or CRUD operations in a MySQL database using Python. You began the module by learning how to create and read records in a database. You reviewed the steps for this process and discovered how Python communicates with a database to carry out these actions. You then learned how to perform MySQL update and delete operations using Python. And you learned how to commit the changes to the database. You completed this first lesson by performing a series of lab exercises in which you demonstrated your ability to carry out CRUD operations in a MySQL database using Python. In the second lesson of Module 2, you learned how to perform advanced queries in a MySQL database using Python. The first of these queries involved filtering and sorting data in a MySQL database using Python. You recapped the basics of MySQL filtering and sorting techniques from earlier courses and learned how these same techniques are applied to Python. Next, you learned how to perform a range of different join operations to join data from different tables in a MySQL database using Python. You then received an opportunity to test your ability to perform advanced queries in MySQL database using Python through a series of labs. Module 3 focused on advanced database clients. The first lesson in this module began with an overview of how to use MySQL functions with Python. You began by learning how to identify the importance of MySQL functions, and you reviewed the different types of functions available in MySQL. You also learned how MySQL makes use of functions using Python. Once you finished recapping the basics of MySQL functions, you then learned how to implement or access MySQL functions using Python. You also explored datetime functions in Python and learned how to make use of these functions to update a MySQL database using Python. You then demonstrated your ability to make use of these functions in lab exercises. In the second lesson in this third module, you explored how to use MySQL stored procedures with Python. You recapped the basics of stored procedures and learned how they differ from functions and why they're used with Python. You then learned how to access stored procedures through Python with the use of the callproc method. And you also reviewed the use of delimiters. The third and final lesson in this module focused on connection pools. You began by developing an understanding of the concept of database connection pooling. You learned how to explain database connection pooling, and you learned how to identify the advantages of database connection pooling. You then reviewed the steps for creating a connection pool for a database, including the process for implementing the connection pool SQL module. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've reached the end of this course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your MySQL journey, and you should now understand database clients. You were able to demonstrate some of this learning along with your practical MySQL skill set in the lab project. Following your completion of this lab project, you should now be able to interact with the MySQL database using Python, perform queries in MySQL using Python, and make use of MySQL functions, procedures, and connection pools. The graded assessment then further tested your knowledge of these skills. However, there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next one? You'll continue to develop your skill set during each of the database engineer courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. But the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates, or take other fundamental courses once you earn this certificate. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.